we are keen to improve the paper properties, we are keen to improve our production, and we are keen to reduce the breakages during the paper production. So there are various factors which ultimately affects the quality of the paper, as well as you can reduce the number of breakages during the paper making, as far as you are well aware of the wet end chemistry which is involved in the your paper making. So this is all my presentation will include all these aspects. What are the basic I'll start from the basics of the paper making. What are the basically, you know, are the raw materials and characteristics of the raw materials, apart from the what are the different pulping processes which are used in the for the making the pulp out of the wood. And apart from there will be wet end chemistry phenomena, like what is the colloidal science concept that will be there. So I'll start here with my first slide, the paper making raw material and fiber characteristics. The raw material which is widely used in paper making is the basically you all knows that is a cellulosic pulp, and many of the fibers are the cotton fibers, and cellulosic fibers are used to produce the paper pulp. And the pulp which is coming from the our wood and non-wood material, as well as from the our agro residues like wheat straw, rice straw, and bagasse. So pulp basically is a basic and most important ingredient for paper making, and it is the major raw material that is used in the largest fraction in the other material on the basis of their source medium. The pulp is again categorized as wood pulp, as I have already told you. Wood pulp, which is wood includes various type of woods are like eucalyptus, casuarina, and your popular mango trees. And so these are all your wood pulp. And non-wood includes your cotton, linen, and hemp fiber, straw, bamboo, spatograph, grass, and other alternative materials which are being used as a non-wood pulp. And recycled pulp, as Dr. Ram has already explained about the recycled pulp. And there are other sizing material. Sizing is basically are the material which are used to provide the hydrophobicity to the paper, because you might have seen when we are writing with the we are using ink pen. So there is a hydrophobicity required, so that ink is not spread over the surface of the paper. So we need to add some sizing agent on the paper, and that sizing agent can, mostly the sizing agents are added at the wet end. Wet end means during the paper manufacturing, before paper making manufacturing, during the stock preparation only. And there then comes the filler materials. Fillers are your inorganic material which are added to improve the aesthetic properties like opacity, your brightness, your whiteness, so that your paper looks very bright and aesthetic, to improve the aesthetic look of the paper and to reduce the fiber, because fiber is very costly. In order to save that costly fiber, we paper industries are keen to increase the inorganic content present in the paper, that is called fillers. Fillers are basically your talc, GCC, ground calcium carbonate, PCC, precipitated calcium carbonate. So these are all the filler. And pigment and coloring material. Pigment and coloring material are dyes, which are basically the special kinds of dyes which are added at the stock during the paper stock preparation to impart a specific shade to the paper and color to the paper. There are various parameters which should be taken care of. First is the composition, consistency, as Dr. Ram has already told, and pulp draw, pH, alkalinity, colloidal charge, zeta potential, soda carryover, and hexanuronic acid content. So these are the various parameters we should be first of all taking care when you are making a pulp, and that pulp is going to make, you are going to make the paper out of that pulp. So these are the basic parameters. Apart from, there are a lot of other parameters, but first of all, if you want to make a very good quality paper, and you move your paper machines with smooth running, so these are the various parameters we should be first of all taken very great care of that, alkalinity and right, all these parameters. And there are other parameters like stock and backwater. The backwater is a water which is drained through the paper machine and getting recycled. We have to recycle that backwater for during the stock preparation. So there are other parameters which are involved, very essentials to be maintained during the backwater recirculation. First is the pH, which is a negative logarithmic of the hydrogen ion concentration, and second is the consistency, freeness, alkalinity. Alkalinity, there are two type of alkalinity. You might have all known that alkalinity, P-type alkalinity, phenolphthalein alkalinity, and M-methyl orange alkalinity. So this is the about this is the, and third is the hardness. Hardness is the level of the calcium and the magnesium ions which are responsible for the making your water hard. Hardness is a very important parameter. So it should be in the range of 200 or 250 ppm, not more than that. Sometime I have gone in some regions during our plant trials. We have formulated some material and we are going for the plant scale trial. So we faced a lot of problem during that plant trial, because as we analyzed, the quality of the water was very we were not knowing what is happening between what is the chemistry hidden, why that chemical is not at all working. So we analyzed the quality of the water. You will see the quality of the water in terms of alkalinity, in terms of pH and hardness. Hardness was more than 1000 ppm. Can you imagine can you imagine to make a paper which is having a hardness more than 1000 ppm? So we use some chelating agents to neutralize that hardness, to bring down that hardness to a level of 200 or so. So that is also the main point of telling you is that is the very important parameter. Hardness, alkalinity and hardness of the water has to be maintained, and you should know what is the level of hardness, but you should know what is the level of the alkalinity. Ionic behavior and charge demand of the pulp slurry again is a very important parameter. That I will explain in detail in my subsequent slides. Ionic behavior of the charge. Basically, you all know that pulp is a cellulosic, contains OH negative group. That OH negative group imparts the anionic characteristics to the pulp stock, and we have to use that anionic nature of that cellulosic fiber so that our cationic additives are better untangled or better making the hydrogen bond with our cellulosic fiber. So pulp is having having anionic charge, OH negative, and that charge demand of the pulp slurry we should know before sending our stock to the head box. We should know what is the basically the charge of the pulp stock. It should be somewhere I will discuss in detail. It should be somewhere in anionic. There should always be a cationic demand into the system. It means your cationic additives, whatever the subsequent stages you will be adding, where various cationic additives, I will explain in detail what are the various cationic additives and what are the functions and why we are adding those cationic additives. You cannot add your cationic additives without knowing the wet end chemistry. So it is not up to the your chemical suppliers. Sometime without knowing the chemistry, they will tell you, yeah, some of you might be there dealing with such kind of problems during your day-to-day routine activities during the paper making. So you will feel that once you have started adding any chemical, so you might face some kind of problem because you don't know what is the chemistry and what is the basically charge at that point where you are adding, what is the charge of that your chemical and what is the charge, colloidal charge, as well as your zeta. There are a lot of parameters I will explain in detail. So what is basically is the colloidal charge at that time. So that should be kept in mind if you want to improvise your wet end chemistry. That will ultimately improve the productivity and the quality of your paper making. So this is a very important parameter for you guys. And zeta potential is again the strength of interaction between the negatively and the positively charged particles. Basically negative is your hydroxyl group which is having a OH negative group, and positive you are adding various cationic. Most of the cationic additives are having positive charge, most of the, except your optical whitening agents that are anionic in nature. Apart from that, most of the additives which are being added in the wet end are mostly positive. So you have to take care that zeta potential. Zeta potential of the pulp is basically a surface charge, not a colloidal. There are two type of charge you have to maintain during the maintaining the head box properties before making the paper. First is your colloidal charge and your zeta potential. Colloidal is a dissolved form. Colloidal charge is in dissolved form, and your zeta potential is a surface charge, basically strength of interaction between the negatively and positively charged particle. I will explain in detail what is the zeta potential so that you can better know. So this is the fiber unit structure. Fiber seems very simple when you see under microscope. You will see this is the layer of the fiber, but there are different layers present in the fiber. First one is the primary layer, then is the secondary layer, then is the tertiary layer, and then is the lumen. Primary layer is the thickness of the primary layer is very low. Then comes the S1 layer. S1 layer, the thickness is again not a and third is the secondary layer. Secondary layer is the thickest layer of during this fiber morphological characteristics. Okay, it contains mostly the fines which are generating. Suppose that Dr. Ram has already explained about the Schopper-Regler test. So Schopper-Regler test is basically a test which is used to determine the freeness of the fiber. Once we are giving the mechanical action, we are refining our fiber. So what refining is basically is a mechanical action which is being given to the fibers to fibrillate that fiber. Fibrillation is required. Why the fibrillation is required? Fibrillation is required to make the hydrogen bond with the other fiber. Once suppose there is a latent fiber which is not given any mechanical action, so that will be difficult to make the hydrogen bond with the other fiber. So it is always better, it is recommended to make a mechanical action should be given to the fiber, and that mechanical action first of all will attack on your primary wall, then will attack on your secondary wall, then will attack on your S2 layer. As far as that mechanical action will reach to S2 layer, most of the fines and fibrils will come out of the fiber, which are basically are the responsible for making the hydrogen bond and for making the improving your porosity, you're improving your freeness, you're improving your all strength properties. So your mechanical action should not be in that way that will cross your secondary layer and will reach to the lumen. So this is the way, so you should take care of that, and these are the various characteristics. You might have seen this is the pointer काम नहीं कर रहे क्या? अच्छा okay. This is the basically यहाँ नहीं दिख रहा है, इधर नजर नहीं आ रहा है, चलिए ठीक है okay. This is the fiber structure. Basically you might have seen the primary layer. Here you will see this is the primary layer, secondary wall, and बीच में जो red है, this is the middle lamella, and these are the microfibrils and macrofibrils. Then from the secondary layer you will get the microfibrils. Then after that the cellulose molecules will go, which are basically required for the better interaction of the cellulosic fibers. So this is the basically the chemistry. This one C1 is the your SAM, scanning electron micrography, magnifying image, how the fiber look like if you magnify your fiber which is refined. You might have seen that the primary layer as well as S1 layer, then S2 layer, these are the various layers. So cellulose is basically a crystalline structure, having a crystalline structure, while hemicellulose is amorphous in nature, and your hemicellulose surrounds cellulosic microfibrils. Hemicellulose has a lower strength than cellulose and can be easily hydrolyzed. Hemicellulose also present in pulp, but it is detrimental to the paper properties. And third component of the cell wall is the lignin. Lignin is basically, what is lignin? You might have heard about the lignin. Lignin is present in pulp. So that lignin is basically, we don't need lignin for making. This is a binding material, this is a cementing material which we need to extract it out for making our good quality paper. All of these components are present in different layers of the cell wall. Then comes the type of pulping. Type of pulping, you might have all know about the type of pulping. There are various types of pulping, like one is the soda pulping where NaOH is used, at the particular temperature and pressure for making the soda pulping is basically used for your agri residues, like basically for the bagasse, wheat straw, rice straw. So that soda pulping is used there. And for your hardwood, you need kraft pulping, which includes your sulfate as well as sulfide. So that is along with your soda, you need sulfidity also. That is a kraft pulping is required for the pulping of the hardwood. Then is the CTMP. CTMP is the chemi-thermomechanical pulp. It's a mechanical pulp. First is the sorry, I forgot. First is the mechanical pulping, then is your soda pulping, then thereafter is your kraft pulping. And CTMP is the chemi-thermomechanical pulping. It's a sort of mechanical pulping, but along with that you will have to give the chemical treatment along with some temperature. Temperature is also required. That is just a mechanical action is given to the wood log along with the chemical treatment as well as your giving your temperature to your water. Then is the thermomechanical pulp, or the one of the popular type of mechanical pulp. Thermo means though no chemical treatment is given, only thermal treatment to the water is given, and with the mechanical action is given to the wood log. Then the mechanical pulp, basically you might be knowing that it contains most of the lignin. Is you cannot extract out lignin during the mechanical pulping, because lignin is the cementing material which presents in the stem of the tree, and during the mechanical action that lignin will not go anywhere, is not going to get unless and until you are giving any temperature, you are giving any chemical shock to that will not go out. So mechanical pulping में ज़्यादा lignin present रहता ही रहता है, more than 90%. So pulp refining is very, I have already explained that refining is a mechanical action given to the fibers to improve the, and charge happen to the electrokinetic properties of the fiber. Wood fiber develops, as I have already told, that wood fiber develop a negative charge. That will be more clear with your subsequent slide. Wood fiber develop a negative charge when suspended in water, and the level of anionic charge on the pulp supplied from the wood pulp is typically -20 to 25. This is the charge present in the, when you are taking a pulp to make a paper, initial charge of the pulp range in the between -20 to 25. You can bring down that level of the charge by addition of your wet end chemicals at a level of light like around -6 or -7. You should not starting adding your chemicals. You should not over catenize your system so that your charge should not be neutralized, and there should not be any shifting from your negative to positive. In that condition, you will lose your paper properties, sheet formation will be very poor, and your paper breaks will improve, and you will not be able to make a good quality paper, and you will, this is just because of this charge only. So this is the basically a schematic diagram where the stem is used, remove the unwanted portion like bark, debarking. After that the cleaning is done, then chipping is done before making the pulp. This is the treatment given to the wood log. You might have all be aware of this, and this is a very basic chipping, thereafter digesting after washing, screening means to remove the dirt and other specks present in the pulp, and screening after bleaching. Maximum portion of the lignin is removed during the pulping. When you are following this is the digester. We are using various digesters for making the pulp. So most of the lignin is removed during the pulping. Lekin still we are getting a brown grade of pulp, brown color of pulp. Why that brown color of pulp is that? Because of the lignin present. So we need to remove that lignin during the subsequent stages and during the pulp bleaching. And we should take care of the fiber shrinkage during the bleaching, because we should not overdose the bleaching chemicals to get our final brightness. You have to maintain the viscosity of the pulp is a very important parameter during the bleaching stages. So viscosity has to be maintained during the bleaching. That is measured in CP, centipoise. You cannot start adding your bleaching chemicals to get a target brightness level. So keep a close watch on the this kind of properties like viscosity. And after that, getting the screening, bleaching, then refining, as I've already explained. Then freeness level, check the freeness level. Suppose it is around 30 to 28 degree SRO, depends on the end use of the proper paper and type of paper you are making out of that. And cleaning then goes to the paper machine, your stock preparation for paper making. Then comes the wet end chemistry. Wet end chemistry is basically focused on the two main aspects. One is the achievement of the paper properties, and second is the enhancement of the paper machine runnability. So as I've already explained that these two parameters, these two aspects you should keep in mind so that you can improvise your wet end chemistry. And the first objective is aimed at meeting product specifications set by customers. And second category is most important to the paper machine productivity, and where there are various paper properties like structural properties. Like structural properties include your basis weight, your caliper is your thickness, and your formation, directionability, your two-sidedness, porosity, as well as your roughness of the paper. And then mechanical properties include your strength properties like tear, tensile, burst, stiffness, folding endurance, and your internal bonding strength, jet directional strength, and your surface strength. Apart from that, appearance of the paper is color, brightness, opacity, yellowness, your tint, and your gloss. And then comes the barrier properties. Barrier properties includes your core value. You might have heard about the core value. You know the core value? Core value, what is core value? Yes, core value is basically, I have asked this question, I just wanted to see what is the level so that I should go in detail. Yeah, basically core value is a properties of a paper which is basically is measured to check the hydrophobicity of the paper, resistance to water, how much whatever the paper you have made, how much that water is resistant to paper. हाइड्रोफोबिसिटी चेक करने के लिए को वैल्यू एक पैरामीटर है, इन विच को वैल्यू 100 ml ऑफ वाटर लिया जाता है पेपर के ऊपर डाल के, उसको 45 सेकंड्स बाद उसको देयर इज अ टेपी टेस्ट स्टैंडर्ड है, उसका आईएस मेथड है, टेपी टेस्ट मेथड है, उससे आप उसको करते हैं पेपर में हाइड्रोफोबिसिटी चेक करने के लिए. दैट हाइड्रोफोबिसिटी इज मेंटेन्ड विद योर साइजिंग केमिकल्स. एंड व्हाट आर द साइजिंग केमिकल्स? अर्लियर पीपल यूज्ड टू, देयर आर टू टाइप ऑफ बेसिकली साइजिंग, acidic sizing, neutral sizing, three types: acidic sizing, neutral sizing, and alkaline sizing. Acidic sizing are gone are the days when people used to make the paper with the acidic sizing. Now it is the neutral sizing. People are using rosin as well as LM. Now gone are the days when people used to use that neutral sizing. Now people are using alkaline sizing. In alkaline sizing there is alkynyl succinic anhydride, alkyl ketene dimer. These are the two main components which are being used for making a hydrophobic paper. So our paper industries are keen to use nowadays to utilize ASA, AKD and ASA. These are the two alkaline. Most of the Indian paper industries are moving towards to use that alkaline, because if you use acidic sizing, so neutral sizing cost a lot, PSC cost a lot, your rosin cost a lot. Your alkaline sizing material are very reactive fast sizing agent. Immediately on machine sizing will give your ASA will give you on machine sizing, and at Popril you will get a very after curing you will get a good core value during your AKD sizing. So these are the two very fast reactive sizing agent and very cheaper in comparison to your alkaline. Yes, please. Yes, alkyl ketene dimer, ALKYL KETENE, ketene dimer, AKD. And third one is your alkynyl succinic anhydride, ALKENYL succinic, SUCCINIC anhydride, ANHYRIDE. So people are basically moving towards ASA. ASA is a very fast reactive. I am telling you, if you will use ASA, is a very fast reactive sizing agent, but there are some drawbacks of using that ASA. Very few mills in India are using ASA because ASA is a very low shelf life. ASA you will note that ready to use emulsion is not available in the market for ASA. Only ASA oil will be procured from the market. Using the cationic starch, you can make an on-site emulsion out of that, and that on-site emulsion has a very limited shelf life of maximum 15 minutes. You will have to use that emulsion during the 15 minutes. If you are adding that emulsion, that will give you on machine sizing, on machine hydrophobicity you will able to get. In spite of adding your 40 kgs of alum, 60 kgs of PAC, you can use 1.5 kg of ASA. That is, cost is very low, as well as properties are very good. On machine sizing देता है, effluent load पे भी बहुत कम आता है, उसमें इतना treat नहीं करना पड़ता effluent को, लेकिन the main problem is the very limited shelf life, and that ASA can be utilized if your wet end chemistry is totally accurate. You will have to keep a very close watch on your wet end chemistry, and during the wet end chemistry there are various parameters which need to be fine tuned and controlled for effective use of this sizing materials. I will explain. This is the introduction of the wet end chemistry. Basically, you know, importance of the chemical equilibria. What is the importance of the chemical equilibria? Many wet end chemistry phenomena are based on the chemical equilibria, and so the paper maker need to be well grounded in these fundamental aspects. Then comes the importance of particle size specific surface area. Particle surface area plays a very important role during the paper manufacturing, paper making. And then comes the role of a surface charge as well as dissolved charge. Dissolved charge, which is in the dissolved form. When we are making a colloidal suspension or the pulp, wet end additives using water, the charge of the colloidal suspension is a dissolved, which is in the dissolved form. And then comes the zeta potential, is a surface charge. Zeta potential I will explain in detail in next. What is the Stern layer, what is the Nast layer, what is the diffused layer, double layer, electrical double layer. There are a lot of consequences are there, and I'll let you know. The adverse, there are the other interfering substances. You need to control the interfering substances for getting your better paper properties, and these interfering substances with most functional additives and some processing aids. A paper maker must be aware of their existence and be acknowledgeable about their properties and understand how to counteract them in a given situation. Then this is the surface and the colloidal size concept. Colloidal state I have already explained is a state when there is a is a chemical, when the surface chemical properties of dispersed system are important to the overall chemical behavior of the system, only the surface chemical system. The study of the system involves a branch of physical chemistry known as the colloidal chemistry, and then comes, thus paper making is a really colloidal chemistry because of the large specific surface area involved in that. And classification is the hydrophobic as well as hydrophilic. Hydrophobic suspensions are all pigments, your GCC, PCC, these are all dispersed in, these are hydrophobic dispersions, like your fines dispersed, hydrophilic, sorry, hydrophobic, right, hydrophobic hai. Or your rosin size is your hydrophobic dispersion, and your dispersed rosin hydrophobic dispersion. Your hydrophilic dispersion, your starch is dissolved in water, your gums dissolved in water, hemicellulose is dissolved. These are all water loving material, these forms the hydrophilic dispersion. Surface charge will be clear with this slide. This is the electrical double layer existing. You will see these are the negative OH group. This is the pulp cellulosic fiber. When you are adding your wet end additives having a cationic charge, so this cationic charge is coming towards that because there is a strength of interaction between the negatively and the positively charged particle. When these negatively and the positively charged particles are coming closer to each other, then they form an electrical double layer, and the strength of the dead double layer falls in this region. That is the, first of all, you can see with this, this is your Nernst potential. Nernst potential is the potential which is present on the surface of the cellulosic fiber having the maximum negative charge. As you are adding your cationic additives, so your cationic additives, all cationic additives will start approaching towards the negative. So most of the positive charge will approach towards your negative active sites available. So this is the turn potential is, which is the start from here after adding all the negative sides are covered with your positive charge, then they start the turn potential, then is the zeta potential. In this region you will see some of the negative charges there, some of the positive charges there, which is in a colloidal. So this is your zeta potential, the strength of interaction. You can measure here the strength of interaction between the negatively and the positively charged. I am telling you because this is basically a very important parameter, because you need to know what is the zeta potential of your head box before making of your paper. Zeta potential should lie on a negative side, it should not move towards the positive, because if you are getting the value of the zeta potential as your surface charge in the positive range, it means your system is over catalyzed. So you need to control the dosage of your wet end chemicals, otherwise formation will be poor, you will not be able to run your paper, paper breaks बढ़ जाएंगे. So this is basically the electrical double layer existing at the surface of the hydrophobic particle suspended in water. Zeta potential you will have to control by using the, suppose when you are adding your wet end additives, you are adding in during the stock preparation, like you are adding starch, you are adding sizing material, you are adding polyacrylamides. You need to control at this point, you should know what is the level of the charge of your colloidal pulp suspension. Suppose मैंने जैसे बताया आपको पहले starting में था -20 to 25. It brought, you will at the time of adding your starch, you should know what is the charge right now, and after adding that charge कितना कम हो गया, -20 से suppose it is 15, तो there is a scope, वो 0 तक नहीं जाना चाहिए. अगर वो 0 तक चला गया, yes please. Yeah, online control अब तो सर आ गए हैं, online control, yes, you can online charge measurement is there, latent wet end chemistry के जो आजकल latest update है, online charge measurement is there. Otherwise आप, yes please. Sir, actually there is no role of NaOH at this stage, because NaOH, this is the soda carryover you will measure when your pulp is going from your bleaching section moving towards the stock preparation section. You should first of all, there are, I have already explained in my previous slide, there are various parameters which need to be controlled. That is the pH, alkalinity, hardness, hexanuronic acid alkalinity, and your soda carryover also is one of the most. If there is a soda carryover, sodium, it means NaOH is coming in the system, then NaOH you will have to remove, you will have to control that soda carryover. अगर वो otherwise फिर that will create a problem. सोडा carryover पे ध्यान रखिए. Before the head box, during the stock preparation, yes. Online charge measurement is available also in the head box also. There are the probes which are dipped in the head box, then give you the current value of the head box. Online measurement is there. Yes, please. Definitely recycle paper में भी, but recycle paper में still we are not adding so much additives to make a paper. Suppose you are using recycle paper and you are starting adding your chemical for making a special grade of paper. Once you are adding your wet end chemical, then you need to control the charge of the, otherwise recycle में तो इतना नहीं होता है. Dr. Thapliyal is here. He will explain you. Am I right, Dr. Thapliyal? Very tough subject.
Nowadays we have AI and we have some online control measures, so this is now possible. Otherwise you need a very precise control over the addition of your chemicals, chemicals. And it depends on your quality of your product also, what type of product you are manufacturing. Generally recycled fiber, we don't have any writing printing, much of writing printing and specialty grades. That is the biggest problem. So we don't face much of problem there. That is the difference.
I think it's a very vast subject and lot of slides are pending, लेकिन still I hope I have make it very matlab what are the basic concepts so that you can implement in your day-to-day routine activities for paper manufacturing. The main purpose of my presentation was to educate you people for the controlling the wet-end chemistry. There are different kind of charge involved. You need to control the various parameter of the pulp as well as during the stock preparation. So better to control those parameter for making a particular grade of paper. The charge is the main important. To control the wet-end chemistry, you should first of all control your zeta potential, which I've already explained, and your colloidal charge, your pH, your consistency, your alkalinity, your hardness, backwater properties may you need to control. You need to check the backwater charge also. After that, you are adding some retention aids. So that has very high cationic charge, high specific, high charge density, high molecular weight. That is the main, I'm just making it very cut short. Finally, the last material which is before the paper is going, the pulp is going for a head box for making a paper. There are retention aids are being added. These are the polyacrylamides which are having very high charge density material, high molecular weight material. These material are mainly responsible to disturb your charge. So paper industry में क्या करते हैं लोग generally triple retention aid system चला दिया, multiple retention aid system चला दिया without knowing the exact charge of the head box. That if you are not knowing the exact charge of the head box, and in spite of using your triple retention aid system, your dual retention aid system, your single retention aid system, your charge, I'm sure, I'm 100% sure your wet-end chemistry is going to disturb. And
Nowadays we have this tedious problem also with closing of these cycles,
loops, yes. Oh, yes, yes, yes. That is the main problem, na? Because ultimately water has to be recycled. It is mandatory for the paper making. Water has to be recycled. You should first of all emphasize on the wet-end chemistry. This is a very vast subject. It is really not possible for me to incorporate all these slides in this 45 minutes of lecture. I will share my presentation. I have made this presentation in a very layman language so that you can go through the slides. I will request Mr. M.K. Goyal so that he can share the, I think all the presentation will be shared with you guys so that you can, at any point of time, you can contact me for better clarification. So अभी तो बहुत slides pending है sir, तो I will close my session here. Yes sir, I will take.